Hello, continuing our work in logs, we're going to have a look at logarithmic equations. So there are two styles of logarithmic equations in general. You're going to have logarithmic equations where you have the bases the same for all of your logs. So here I have log to the base 3 and log to the base 3. And this is just going to involve combining our logs with the same bases using our log rules on page 21 in our log tables. And then we're just going to solve the equations once we have logs on one side, any numbers or any other business on the other, very much the same way as we would have dealt with square root type equations. And like square root equations, we're going to have constraints on our answers. So I'm going to come back to that at the end of doing this question. We can't have negative numbers ending up inside of our brackets is the upshot of our constraint, just like we had to check that we didn't end up with negative numbers underneath our square roots, if you remember back to when you would have done square root type equations. And then in this type of situation where we have an equation involving logs, where we have logs to different bases, we're going to have to use the change of base formula. There's nothing particularly problematic about using the change of base formula. It's the last formula given to you on page 21, but we're just going to have to deal with that extra step, and after that life is fairly straightforward. I'm going to re-emphasize that an exponential like y is equal to 3 to the x and y is equal to log to the base 3 of x are inverse functions. And a reminder of what that means: it would mean if you put one function inside the other, you just end up with x. They're functions that cancel each other out. Just like the very first ones you dealt with was sine of x and inverse sine, or arc sine, depending on what your teacher would have called it. So those were functions that undid each other. So log to the base 3 of 3 to the x is just equal to x. Now you can see that more clearly by applying the power rule. You would end up with x multiplied by log to the base 3 of 3 to the power of 1, which would just be 1, so you'd end up with x multiplied by 1. But regardless, we have to remember that log and exponential are inverses of each other. And the other thing to highlight, which I have already mentioned here, and is just outlined in blue here, is that there is an underlying assumption. The log functions only work in the way that we expect them to, and thus are only defined for where y, the number in brackets, is greater than 0, whereas is a positive real number. Otherwise, we end up with, if we attempted to use logs outside of the situation where we had a positive number in here, you would end up with functions that would break a lot of rules of what we would expect for most functions. So we say that logs are only defined where we have a positive number inside of our bracket. Now let's jump into our questions. Here we have logs to the same base, so I'm able to use my rules to try and end up with a single log on the left-hand side is equal to anything else I have to deal with on the right-hand side. And then I'm going to use my fundamental rule of logs, or the fact that I have inverse functions, to simplify my equation and get rid of my logs. But let's get into how to apply this. I'm adding two logs here, which means I'm fundamentally adding powers, which means I can use my power rule here. So I'd end up with log to the base 3 of x minus 6 multiplied by x minus 4 is equal to 1. Now I have a single log to a single power, so I could say 3 to the power of 1 is equal to this, or just to highlight, I could say that if I said that both of these things were powers of 3, so this would be 3 to the power of this side, 3 to the power of 1 on the right hand side, which I'd be entitled to do, my 3 to the power of log to the base 3 would cancel each other out because they're inverse functions, and I would just be left with the stuff in brackets is equal to 3 to the power of 1. You end up with identical answers. It's just important to be able to conceptualize both approaches because both will be useful to be able to think through in different types of log questions. So again, we could use the fundamental definition of logs, what we've looked at before. 3 to the power of 1 would be equal to the stuff in the brackets of the log. That's the fundamental definition of logs. Or we could use that 3 to the power of x is the inverse of log to the base 3 in order to effectively cancel out the log part and just be left with the bit in brackets is equal to 3 to the power of 1. Both must be understood and both must be usable in different contexts. The upshot is the same, however. I end up with x minus 6 multiplied by x minus 4 is equal to 3 to the power of 1, which is just 3. Now I multiply out this quadratic, which I know how to do, and when I multiply out that quadratic, I will end up with, so a little bit of work later, x squared minus 10x plus 21 is equal to 0. When I factorize that, which I also know how to do, I will end up getting x minus 3 multiplied by x minus 7 is equal to 0. And then I will end up with x is equal to 3 or x is equal to 7. This is simply working out a quadratic equation. You know how to do that backwards. Now, what we need to keep in mind is our constraint that y must be positive. So again, this links back to work that you would have done before with having to check your equations, check your answers when you had absolute value type equations, or where you would have had square root equations. So if we check x is equal to 3, so I get log to the base 3 of 3 minus 6 plus log to the base 3 of 3 minus 4. We can probably immediately see what the problem is. I end up with log to the base 3 of minus 3 plus log to the base 3 of minus 1 is equal to 1. Neither of these functions are defined. They don't mean anything. So we say this is an invalid solution. Now, x is equal to 7. I have log to the base 3 of 7 minus 6 plus log to the base 3 of 7 minus 4 is equal to 1. I end up with log to the base 3 of 1 plus log to the base 3 of 3 equal to 1. What power of 3 gives me 1? 0. What power of 3 gives me 3 to the power of 1? 1. So 1 is equal to 1. So x is equal to 7 is a valid solution. I must do this check. The final block of marks is for this check, and it is important for you to be comfortable with it in terms of your work with logs. So that's what we do if we have the same base logs and we have an equation. We're just going to get a single log on the left-hand side is equal to anything else we have to deal with on any numbers we have to deal with on the right-hand side. And then we are going to use either the fundamental definition of logs or taking a power of both sides in order to get rid of the logs, and then we're going to solve the equation and check our answers in the original equation that we were dealing with. Now, if we have this situation here where we have different bases, the only extra step is that we have to deal with the change of base formula. That's the one down here. So I'm going to do a little comment here, and I have log of bx is equal to log to the base a of x. So I've changed my base all over, log to the base a of b. So log to the new base of the old base. Now let's apply that to my log to the base 4. I want to turn it into a log to the base 2. Generally, it will be better to go to the lower base. So I'm going to make both of these log to the base 2. So I'll have log to the base 4, 3x plus 1 is going to equal log to the base 2 of 3x plus 1. That's the top line, all over log to the base 2 of 4. Well, what is log to the base 2 of 4? Or that's going to be log to the base 2 of 2 squared. So that's just going to be 2. To recap, log to the base 2 of 4 means what power of 2 would give me 4? And it would be 2 squared. So that is going to be 2. If you're uncomfortable with that argument in an exam, you're entitled to just put this part in the calculator. So I now know that log to the base 2, therefore log to the base 2, 3x plus 1, all over 2 is equal to log to the base 2 of x minus 1. Then I need to get everything in terms of logs. There's actually 2 different ways of doing this problem, but I think the best way to show you for right now is multiply both sides by 2. And get log to the base 2 of 3x plus 1 is equal to 2 log to the base 2 of x minus 1. And then this is I have a number multiplied by a log, which means that it is a power on what is inside the log, what's inside the bracket. So I have log to the base 2, 3x plus 1 is equal to log to the base 2 of x minus 1 to be squared. The power comes inside here, just like we can see it doing in reverse here. Now I have everything log to the base 2, so I have powers equated effectively, so what is inside the brackets must be equal, or if you prefer, we can say that we have taken to the power of 2 of both sides, and that is just going to leave us with what's inside the brackets. When we square this out, we will find that and recognize we get a quadratic. We will end up with x squared minus 5x is equal to 0. I always look for my common factor first, so I'm going to get x on x minus 5 is equal to 0, x is equal to 0, or x is equal to 5 when I rearrange, and I need to do my tests. I need to check both possible solutions. So I have log to the base 4 of 3 on 0 plus 1 is equal to log to the base 2 of 0 minus 1. This solution does not work. I end up with log to the base 2 of minus 1. So I try x to the 5. I get log to the base 4 of 3 on 5 plus 1 equals log to the base 2 on 5 minus 1. I end up with log to the base 4 of 16 is equal to log to the base 2 of 4, and I end up with 2 is equal to 2 when I do a little bit of work on my logs. So you can see here how we have our different methods, and we must always do our checks at the end to ensure that our answers are valid.